Okay. Yeah. Good evening, good afternoon, good morning, depending on where you're watching it from. Tonight we'll be solving assignments, series of assignments tonight on calculus stroke reanalysis. So you're all welcome tonight. We'll solve some problems. I don't know whether the problems we're about to solve is one of your assignments. Thank God you're lucky to have me here. I'm going to break it down for you. Just look at the board. Look at the board. Amen. Look at the board. Okay. Yeah. This assignment is, I think, is from NDA, Nigerian Defense Academy, for PGG students. We have here the question. Question 1, say check for convergence of the sequence, states and use appropriate theory. That is what we want to look at. Please look at the board and copy the question first. Look at the board, copy the question. Please, I want you to like, comment, and share. I'll be very grateful. Okay. So, if you can see what I'm saying, right here we have the sequence. We have it here. You know very well that when we say something is divergent, it means it becomes smaller, smaller, and smaller. But conversion is talking about is doing what? Gradual increments. Amen. So please take note. So now we want to look at, according to the question, check for convergence of the sequence, state and use appropriate theory. Already the appropriate theory is stated here, that if the limit of the general term A of n exists and equals a finite number, that is a limit, then the sequence A of x is convergent and converges to the limit. You know, when we say finite number, you know, finite number, there are numbers that we can count. But when we say infinite, it means it is uncountable. So let us check whether we have a finite number in the limit. So at first, let's write solution and go with me. We now say let the sequence A subscript n be equals to n squared all over n squared plus n. Amen? Yeah. Are you seeing? Look at the board, please. Look at the board. Look at the board. Oh, somebody is trying to help me. It will conversion to 0. Okay, let's see. Hi, sir. I'm from India. You are doing a great job, sir. Oh, India. I can't call your name. Thank you for that compliment. You are welcome. Let's see whether it will convert to 0. Let's see. Okay, so far so good. So it means that you don't need a prophet to tell you, since the denominator, we can factorize the denominator if we have n all in n raised to power 2 plus n. We can rewrite this expression in this form. This is the same thing as n squared, amen, open bracket 1 plus 1 all over n. True of us, look at the board. True of us is true, right? Okay, so if you agree with me, here we are going to have a subscript n is equals to n squared all over n squared, open bracket 1 plus 1 all over what? N. True of us. Then, by the time you multiply this, you still get back this. True of us. Am I making a sense? Okay, so this and this will cancel. So if you agree with me, it means our a subscript n will now be 1 all over 1 plus 1 all over n. So we now take limits as limits tend to what? Infinity. Amen. So you don't need a prophet to tell you. I think somebody mentioned it will convert to 0. I doubt whether it will convert to 0. Look at the board very well. Please just look at it. Look at the board very well. The man from India, what is your name? What is your name, the man from India? Yeah. Yes. So let's do it together. Let's continue. So as you can see now, here, okay. So when we take limits as limits n tends to infinity, it means our a subscript n will now be equals to 1 all over 1 plus 1 all over infinity. True of us. Then this will now be a subscript n is equals to 1 all over 1 plus 1 times 0. Then a subscript n will now be 1 times 0 is 0. 1 all over 1, which is equals to 1. Can you see now? So therefore, our series will now be equals to n squared all over n squared plus 1 is equals to 1. So it converges. So this is how you are going to break it down. If you have any question, please ask so that we proceed to solve more problems. Do you have any question? Any question? No question? No question. You don't have any question? It's okay. If there's no question, let's proceed to solve more problems. There's no question. Let us proceed to solve more problems. No question. So let's proceed. It's okay. Let us proceed to consider more examples. Let's proceed. Yeah, there is no question. It's okay. They said check if the function is continuous. Another question. So check if the function, amen, continuous at x equals to minus 2, that is f of x is equals to x plus 4 all over x minus 2. Okay, so let's look at this together. Look at the board. Let's look at it together. Let us look at it together. Let's look at it together. It's okay. So, we said we should check if the function continues at x equals to 2. I would like us to, consider this. You know, by the theory that polynomials are continuous and quotients of continuous functions are continuous where the denominator is non-zero. Is that clear? Where the denominator is non-zero, since the limit equals the function value. It means if the quotient, the denominator, is not 0 or non-zero, it means the function continues. How do we do that? This is what we are going to do. So we write solution. We now write at f of minus 2 is equals to minus 2 plus 4, right? Then all over, because anywhere you see, here we now be minus 2. So this is equals to minus 2 plus 4 is plus 2. Then all over, yeah, hope I'm correct. Come in. I think here is it square thereabouts. It's okay. Let's continue. Then here will be minus 4, isn't it? Then this will going to give us what? Minus 1 all over 2. True or false? Yeah, it's true. But I think here is it minus 4? here is squared, if I'm not mistaken. If it is squared, here will be 4 plus 4 all over minus 4, which is what? 8 all over minus 4. This is minus 2, right? Please, here is squared. Please, sorry about that. Here is squared. I'm very sorry about that. It's okay. So, here will now be minus 2 all in square plus 4 all over minus 2. Then this is equals to, here we are going to have 4, right? Plus 4. 4 plus 4. I know some of you are confused when you have something like this. Mathematics, this is the same thing as minus 2 times minus 2. Minus times minus plus. So 2 times 2 is 4. So all over minus 2 means you are owing 2 naira, then you go back to go and borrow 2 naira. You add it up, it's going to be 4 naira. Have you paid the debt? No, you've not paid, 2 of us. So it's going to be minus 4. So 4 plus 4 is 8 all over minus 4. 8 divided minus 4, we are going to have minus 2. So for the fact that we get back the function, so it means it is what? Continuous. Please take note. You will discover that the denominator is what? Non-zero. But supposing after everything here is 0, you know that it is not continuous. Please write it down. Thank you. Write it down. Yeah. Where are you watching from? Anades. Anades, where are you watching from? I'm with you. Ubaldo, Anades, where are you watching from? Please talk to me. So, able to yeah. So let's look at more questions. Yeah. More questions. Yeah. More questions. Yeah. Let me clean here. Here is minus 2. So we conclude by saying it is continuous. Amen. Okay. More questions. Let's try to consider more questions. Let's consider more questions, please. You can clean this. Okay, it said, you have a question here. It said, for the given function, by f of t equals to, is a piecewise function, t all over 8 plus 7 all over 4, comma, if 20 is less than or equals to t less than equals to 26, then we have here minus 40 all over 3 minus 175 all over 4, comma, if 26 is less than t less than equals to 39. Amen. He said I determine the domain of f. Then he said find f of 20, f of 26, and f of 39. Yeah. Look at the board. I want to look at this question that will help you. Amen. Amen. Okay. As you can see, okay, all right, solution. At first, we are going to consider I. It said determine the domain of f. The domain of f, if you want to consider the domain, what you need to do, you consider, that is I, the domain of f. You can see that in the domain we have 20 less than equals to t less than equals to 26, then 26 less than t less than equals to 39. Can you see now? So it means for us to find the domain of f, we are going to add this. When we add it up, it means already here t is greater than 26, true or false? Yeah. Then less than or equals to 39, less than or equals to 26. So when we add it up, it means the domain will now be 20 less than t less than 39. I think so. Yeah. Am I right? Yeah. So the domain will now be 20 less than t less than 39. Then let's go ahead to consider I. That is one of them is f of 20, which is equals to what you should consider here first is, instead we should find f of 20 here. Yeah? When you look at the interval, look at this interval. This interval is t is in between what? 20 and what? 26. So it means the function we are going to use is this function. So we now say, since 20 is less than t less than equals to 26, so this 20 is still in between, yeah, true or false. So it means we are going to use this function because of what? 20. So our f of what? 20 is equals to t all over 8 plus 7 all over 4. This is, excuse me, which is equals to, what are we going to do here is f of 20. It means anywhere you see t, you write 20. So here will be 20 all over 8 plus 7 all over 4. Amen. Then this is equals to 2 to 8, 4, 2 to this 10. Can you see now? So if you can see what I am saying, here is going to be what? 10 all over 4 plus 7 all over 4, then which is equals to SN is 4, 4, 2 of us. 10 plus 7 is 17 all over 4. This is how you are going to do it. Please take note. Okay? Then the other one is the same approach. Sorry, excuse me. Any question, please, before we proceed? If you have any question, ask. Any question? Do you have any question? No question? It means we can proceed, right? If there is no question, it's okay. So far, so good. So let's come to consider 26. 26 f of 26 is still in between these two of us because t is less than or equals to what? 26. So is this function that we are going to use? That is, here will now be equals to t all over 8 plus 7 all over 4, which is equals to, anywhere you see t is what? 26 all over 8 plus 7 all over 4. So we can use 2 to 8, 4, 2 to this 13. So this is equals to 13 all over 4 plus 7 all over 4. Then this will now be equals to what? 20 all over 4. Then which is equals to what? 20 divided 4 is 5. True or false? Yeah. Any question? Look at the board. Do you have any question? Any question? Is there any question that you want to ask? Ask your question, please, viewers. Yeah, ask your question. Jubilant song, please ask your question. You said you have a question. I'm waiting for your question, please. Ask your question. Jubilation, ask your question and which country, where are you watching from? Oh, you are watching from Nigeria. You said this is not calculus, it's calculus. We are looking at piecewise functions now, both calculus and reanalysis. You said you just joined, yeah. This is both calculus and reanalysis. Your elementary calculus, although you know sometimes lecturers refuse to teach all this, not everything they teach. True or false? So I know all through your ND or HND, or you've not heard of reanalysis. Oh, sorry about that. It is also a branch of mathematics, reanalysis. functional analysis and the rest is okay. So that is that. So now let's consider uh, let us consider this f of 39. F of 39 lies where? This function, true or false? Yeah, because 39 is bigger than this, so it won't, you will not make use of this function, rather is this function. So here will now be equals to minus 40 all over 3 minus 175 all over 4, right? So this is equals to, anywhere you see t, you write 39 minus 4 times 39 all over 3 minus 175 all over 4, right? So let's multiply 39 times 4. This will going to give us what? 36, right? Carry 3, 12, 15, 156. True or false? Yeah. So our f of 39 is equals to minus 156 all over 3 minus 175 all over 4. So here the LCM is going to be what? 12. True or false? Look at the board. The LCM of 3 and 4 is going to be 12. Yeah. It's going to be 12. Any question? It's going to be 12. So far, so good. So in the long run, we are going to have minus 3838 all over 4. This will be the final answer. Any question, please? Ask your question, please. Any question? You said I'm good. I'm not good. I'm still learning. I'm not good. I am still a learner. But thank you for the compliments you are giving to me. I'm still learning. Thank you for the compliments. I'm still learning from you also. You are welcome. Jubilation. You are welcome. I'm not good. I'm still learning. Thank you very much for your compliment. So, do you have any question so that we proceed further to consider more problems? Huh? Any question? Oh, you want us to do calculus of several variables? No problem. I can assist you if you are ready. Yeah, get a book. Get a book. Yeah, get a book. I will just show you how we are going to do it. Get a book and writing material. We are going to solve some examples here. Get a book. You want me to do calculus of several variables? It's nice, no problem. But I want you to share what you are learning now. Please, jubilation. Jubilation, please share what you are learning on your Facebook, TikTok, Twitter, or WhatsApp group. I want you to do so. As you want me to help you, I want you to also help me to share my page. Make sure you subscribe to it. Jubilation. Did you hear me? Since you want us to do calculus of several variables, share it on your platforms, the group you belong to. Is it a departmental group or Facebook or anyone? Please do so. I'll be very okay. In case you have any challenge and you want me to put you through in any of the mathematics courses, this is my WhatsApp number, my call number, 2347033667737. Yeah. So this is my number and this is my name. This is my name. So please take it down so that you can chat me up. In case of next time, I'll be there for you. I will be there to help you, please. In case of next time. Yeah, share it in your class group. Then this is my WhatsApp number, both Facebook, TikTok, X. Yeah, I'm from Nigeria. I'm from Nigeria. Yeah. So are you ready now so that we start the class? Are you ready? You said we should consider several variables, right, in calculus. Okay, if you are ready, it's okay. Let's look at it. Have you taken the number so that you can chat me up? The number is there. So that in case you have any mathematical problem, challenge, sometimes your lecturer might give you assignments or past questions. Snap and forward it to me. I will solve all of them for you. Snap your past questions and send it to my WhatsApp. Take the number there. It's okay. So let's start. Let us look at functions of many variables, right? Functions of many variables. It's okay. It's not difficult. As simple as ABC. Yeah. When we say functions of many variables, let me just consider, let's try functions of one variable. When we say functions of one variable, look at it. When you have a function, f of x equals to y, this is a function of what? Function of what? One variable. Is that clear? But one variable, function of one variable, then by the time you see f of x, y, this is function of what? Two variables. One variable, this is two variable. Take notes. Is that clear? two variables. Then by the time you come across functions f of x comma y comma z, this is function of what? Three variable, which we can refer it as what? Function of what? Many or several variables. Do you understand? Do you understand? Okay. Do you understand, right? It's okay. So sometimes you might be given questions of this form. Let me say if y, amen. If let me say if f of x comma y equals to x square y plus y square x. Then we now say find I f of 1 comma minus 1 and f of minus 1 comma 2. Have you come across something like this? Look at the board. Can you see now? So how can we handle this type of cases or case? I'm going to show you, I'll teach you how you are going to handle it. It's okay. So what we need to do, let's write solution. As you can see, it means you can now see that this is function of what? Two variables, two of us. Look at it. We have 1 comma minus 1. So it means you don't need a prophet to tell you. It means your x is this, your y is minus what? 1. Because in the coordinates, it is always x comma what? Y. Take note, very important. So a solution, it means our f of 1 comma minus 1 is equals to x squared y plus y squared x. So this implies that anywhere you see 1, you write, anywhere you see x, you write 1. Anywhere you see y, you write minus what? 1. So here we are going to have, this is equals to 1 times, but 1 here is squared, then times y is minus 1. Then what we have here, plus y is squared minus 1 all in square, then x is 1, right? X is 1 times 1. Can you see now? So if you can see what I have seen, our f of 1 comma minus 1 now be equals to 1 raised to power 2. 1 raised to power 2 is the same as 1 times 1, which is 1. So here will be 1 times minus 1 plus, when we have minus 1 all in square, this is equal to minus 1 times minus 1, which is minus times minus. Give you plus 1 times 1 is 1, right? So here will give us 1 times 1. Amen? Are you following? So this is equals to 1 times minus 1 will give us minus 1, then plus 1 times 1, 1. You can now see that minus 1 plus 1 is 0. So the answer will now f of 1 comma minus 1 is equals to what? 0. Please, do you have any question? Look at the board and ask your question. If you have any question. Zubilan. Jubilation. Any question? Do you have any question? Please, this channel will help you very well. Subscribe to it. I have over 400 videos talking about calculus, advanced calculus, real analysis, numerical method, algebra, elementary algebra, and the rest. So subscribe to it, go through the videos. You will see a lot of solved problems of JAMB, NECO, WAEC, Junior WAEC, and the rest. I have over 400 videos. So take your time to go through the channel. It will do you good. Then, as I said, don't forget to chat me up, forward your past questions, your mathematics past questions, so that I will prepare you. I'll be live like this to solve your past questions for you, so that it will do you good. Is that clear? Jubilation. Are you following? Okay, so let's move further to solve the second problem. It said here, set f of what? F of minus 1 comma 2, right? So this is equals to x squared y, amen, plus y squared x. Then this is equals to, this is x, right? And this is y. So here will be minus 1 all squared. Then y is 2 plus 2 all squared times minus 1. True or false? True or false? Jubilation. True or false? It's true, right? So far, so good. Our f of minus 1 comma 2 is equals to, this one will give us 1 times 2 plus this one will give us 4, right? Because when we have 2 is equal to 2, this is equal as 2 times 2, which is equals to 4. True or false? Here will be 4 times minus what? 1, isn't it? So our f minus 1 times comma 2, 1 times 2 is 2, 4 times minus 1 minus 4 times plus minus 4. So this will going to be 2 minus 4. We are going to have minus 2. So it means our f of minus 1 comma 2 is equals to minus 2. Do you have any question, please? Jubilation. Any question? Look at the board. Hope you are understanding. Jubilation. Hope you are understanding. Are you understanding what I am teaching? Hope you are understanding what I'm teaching. I think you sent the past questions, right? Do you understand? So let's move further to solve one or two problems. Then we call it a day. I will be live tomorrow morning by 9, exactly 9. So don't forget to join me. I'll be teaching secondary school students. I used to do my community service at government college, Kurumanshi, Kaduna. So yeah, I've seen it. So let's look at my example. So hopefully tomorrow you chat me up. It's okay. Yeah. Let's look at if we have f of 0, 1, 2. Oh, sorry. If we have x, y, z equals to cube root of x square yz plus x y square z, and we said find f of f of 1 minus 1 and 1 all over 2. Yeah, so let's look at this example. This is a beautiful example. I'll go through it, but not this night. That will be tomorrow evening. You chat me up when you are ready for the class. I will come live. Is that clear? So let's look at this example. This is a very good example that we want to look at. So you can now see that it's a function of many variables. Can you see x, y, z? I don't know whether you've been taught something like this in your class. Okay, yeah, so let's look at it together. So we are going to conclude with this example. We'll continue on tomorrow. So here we have the function f of x, y, z is equals to cube root of x square yz plus x y square z square. So now what we need to do is here is f of 1, minus 1, 1 all over 2, right? So it means your x is 1, y is minus 1, true or false? Z is 1 all over 2, right? So here we are going to have f of 1, minus 1, 1 all over 2 equals to, look at it, equals to cube root of this. Anywhere you see x, write 1, but x here is squared, right? So 1 raised to the power of 2, then times minus 1, then times 1 all over 2. What we have here plus the same thing applicable, 1 times minus 1 all in square, then z is raised to power 2, then open bracket, which is z is 1 all over 2, 1 all over 2 all in square. Are you seeing? Are you seeing what I'm trying to do? Can you see what I'm saying? So our f of 1 comma minus 1 comma 1 all over 2 now be equals to cube root of this is 1 times minus 1 times 1 all over 2 plus 1 times this will give us 1 times when we have 1 all over 2 all in square is the same as 1 all over 2 times 1 all over 2, which is equals to 1 all over 4. True or false? Plus 1 times 1, 1. 2 times 2, 4. So here will be open bracket 1 all over 4. Okay. So let's proceed. We have our f of 1 comma minus 1 comma 1 all over 2 is equals to cube root of 3, then 1 times minus 1 times 1 all over 2 minus 1 all over 2 plus 1 times 1 times 1 all over 4, 1 all over 4. Are you following? Please look at the board. Hope you're understanding. Yeah, those questions, like I said I will go live tomorrow by 9 a.m. but I will be looking at secondary school students. I'll be teaching secondary school students live at 9 a.m. tomorrow morning. I'll be taking them JAMB, NECO, WAEC questions. I'll be taking them JAMB, NECO, WAEC questions. That's SS1 to SS3. So I said you have my number. You can chat me up night like this in the evening. So if there is light, if you are ready, I will begin to solve those past questions. But for now, let's finish this one. Is that clear? Let us finish this. So at this point, what are we going to do? What are we going to do at this point? We look for LCM. So let us do it side. Here we are going to have minus 1 all over 2 plus 1 all over 4, right? So this is equals to 1 all over 2 plus 1 all over 4. As you can see now, the LCM will be 4. So 4 to 2, 2 times minus 1 minus 2. What do you have here? Plus 4 to 4, 1 times 1, 1. So you can now see that minus 2 plus 1 is minus 1 all over 4. It's okay. So here is our f of 1 comma minus 1 comma 1 all over 2 is equals to cube root of minus 1 all over 4. Yeah, this is where we can stop. Do you have any question, please? Any question? Do you understand? So please subscribe to this channel. Make sure you share it with your friends. Share this platform with your friends. Do you have any question? Do you understand? So you can now see that functions of many variables or several variables is not difficult to calculate. True or false? But sometimes depend on who is teaching you. Do you understand? Are you following? Okay. Yeah, so this is how far we can go. At this point, I'm going to call it a day. Thank you for your time. I love you guys. Please don't forget to like, comment, and share. See you again, same time, same venue. Bye. I love you. Thank you.